Hi everyone and welcome to today's session. We're going to be doing live coding with containers. My name is Chris Bernard and I'm a senior developer advocate with AWS. This is our agenda for today, but just before I go through this is a coding session, so there are only about 4 or 5 slides that I'm going to be going through to illustrate some of the concepts we want to cover today, and then we're going to hop over to the console, and then we're going to work through everything via the AWS console. So during our demo today, I will show you how to use image scanning with Amazon ECR. So when you push a Docker container, we'll do an image scan to scan for vulnerabilities on it. And then I'll also show you how you can actually integrate that and take action if you do find any kind of vulnerability. Then we're going to look at auto-scaling group allocation strategies in terms of how you can spread your allocation across different instance types and instance families, and then also combine that with weighted auto-scaling groups where you can assign different weights to the different sizes of instances you're spinning up to decide how many of them to spin up. As part of that, I'm going to quickly explain to you how EC2 instance pools work and how they take into account the weighting that you allocate to the different instance types that you pick in your auto-scaling group. Then we're going to move over to ECS cluster auto-scaling, and this is where you have the ability to create an ECS cluster with no EC2 instances running, or let's say a certain amount that you have, and then depending on how many containers you launch or tasks you launch on that cluster, it'll actually increase the cluster to accommodate this capacity need that you have. Then I'm also going to show you how to blend on-demand as well as spot Fargate capacity. We're using the AWS Fargate capacity provider. And like I said, everything is going to be in the demo. So let me quickly show you the slides that we want to get through today. So the first concept we have to cover today is Amazon EC2 Spot Instance pools. And when you look at this grid that you see on the left there, you can see that we are currently dealing with the C4 instance family. We also have a bunch of different sizes for them, and then also the different availability zone where they are available. And this pricing differs in every single region. So spot pricing is different per instance size, per availability zone, per region. And this gives you one of these blocks, which is a separate spot pool when we refer to that in this presentation going forward. Then also this differs across all the different instance families as well. So now that we know how the spot instance pools work, let's take a look at how the capacity optimization allocation strategy works with the auto-scaling groups. So what you can see on this slide is that we have got an allocation strategy of capacity optimized. Now what you can see in the middle of each block is the 3 different instance types that we're dealing with. There is a R5 large, M4 large, and an M5 large. And the bar on the right of them indicates the amount of capacity available inside that availability zone of that specific instance type. On the left, you can see that the dollars indicate the current pricing of that instance. $1 is the cheapest, $3 is the most expensive. Now, with the capacity optimized allocation strategy, what we are saying is that we want to pick whichever of the different instance types that we specify in this auto-scaling group that has the most capacity in a specific availability zone available is the one that I want to pick, which means that in US East 1A, I'm picking the R5, 1B, it's the M4s, and 1C is the M5s. You can see by looking at the length of the graph, the length of the bar, indicating how much spare capacity is available for that specific instance type. Now you can also choose to go for the lowest price allocation strategy. And how this works is that it will actually go look for the cheapest instance inside the list of instances that you are providing to pick per availability zone and to launch them. And you can see over here it's now changed to being the M4 in the first one, M5 in the second one, and R5 in the third one. So these allocation strategies come into play when you build up a auto-scaling group and you select more than one instance type that you want to use. So in our case, if you look at the overrides there, we had selected the R5 large, M4 large, and the M5 large. And then depending on how you decide to allocate the instances, it'll pick different ones for you to spin up when you increase the size or the required capacity in your auto-scaling group. Now, where it becomes a little bit more interesting is if you start selecting different sized instances, for example, in the same family type, like for example, the M4 extra large, M4 XX large, M4 4X large. Now, what you can do is when you create this auto-scaling group, you can add weights to the different instance types that you select. And what a weight is an indication of the compute operation that it can perform. So let's say you have got your normal workload running on a M4 extra large, and that's what your baseline. You would assign that a weight of 1. then because the M4 2x large is literally double the size of that first one, you give it a weight of 2, because one of those instances can perform the same work as 2 of the normal M4 extra large instances that you had. And then lastly, also, if you've got the 4x large, that one's double up again of the 2x large, which means it's got a weight of 4. And the autoscaling group then takes this into account when you say I have a desired capacity of 6. If it, for example, launched one of the 4x larges and one of the 2x larges, that would only be a physical count of 2 instances, but because of the weighting, that would actually contribute 6 towards the desired instance count. And I'll show you in detail how we're going to do that in the autoscaling group that we are creating. Now that we know the weighting, I just want to go back to this instance pool explain and just add that in. So what you can see in the green column there is the on-demand pricing of the different instances. And if I apply the weight that I have over there to that on-demand pricing, you can see that it's basically the same. There's a fraction of a cent difference in terms of the different sizes of the instances, but basically there's a linear increase in the price depending on the size that you pick. Now, where it becomes fun again is that when you start looking at the different availability zones and you calculate this weight into the actual cost of the per hour of running that instance. So now what we can see over here is that there's quite a bit of difference between the different availability zones as well as the different instance sizes. For example, if you look there on the right in the 1C availability zone, second from the top, the 4XL is 2 cents per hour, where the one in 1B is 3.8 cents per hour. So this is how the weighting also plays into the factor of picking the cheapest instance to launch based on that cost optimization strategy that we have. We're now going to head over to the console, and I'm going to start off by showing you how to enable image scanning on ECR. Okay, so I'm now inside the AWS console and I navigated to ECR in there. We're going to be creating a repository quick. We're going to be calling it Online Summit for today. And then we've got 2 options available here. The first one is tag immutability. Now this means that when you enable it, you are no longer able to push a newer version of the same tag. So if you enable this, it means that if I've got something like v1.0, I can never replace that unless I come and manually delete that image. And it's a good practice to not replace those images. So I would recommend enabling this. Then the one that we are interested in is the scan to push or scan on push. We want to make sure that we don't have any vulnerabilities in our instances or images when we spin them up. So let's go ahead and create this repository quickly. Okay, so our repositories have been successfully created. So I'm going to go in there and we can see that we don't have any Docker images in here yet. Now you can click on here for the push commands to get the commands that you need to use to actually log in. So we're going to grab this first one because we're going to head over to Cloud9 to actually play around with the containers. So Cloud9 is just our web-based IDE that I'm going to use for our demo today. And I paste in that command. And we will see that it will log me into the ECR repository. Now what I've done is I went to look for a fairly old Docker image, specifically Ubuntu Trusty, and you can see that this is a 2016 image. So we're just quickly pulling it, and then what we're going to do is we are going to push this into our ECR repository and see what happens. Now that we've pulled the image, I'm going to quickly tag it with our ECR repositories URL and repo name, and we're going to give it the tag not latest, and let's just call it very old for now. Okay. Now, the last step will be to actually push this to our repository. So let's go ahead and do that. Now you can see it's going to take a few seconds just quickly to push the rest of the container. Now that it's done, let's head back to that repository and do a quick refresh. And what you can see over here is that immediately it indicated there are 4 vulnerabilities. So let's open this up and actually see what it says. So what we can see is this one has got 4 high vulnerabilities. It's got 82 medium, 94 low, and 34 informational ones. And if you want any specific detail, you can look at the different ones over here. So for example, I can click on this link and it'll actually take me to a specific page on Ubuntu's home site where I can see the details about this specific CVE. So this is how you would know what issues are inside a specific container as soon as you push it to ECR. But let's say you want to take some kind of action when you pick up some high or critical CVEs. Let me quickly show you how we're going to do this by creating a small Lambda that's going to interrogate the JSON payload that it receives from Amazon Event Bridge. So let's quickly open up our Lambda console. which is over here. And we are going to create a new function. So we're going to use author from scratch, and we're going to call this ECR CVE scanner. And we're just going to use the default Node.js runtime over there. So let's go ahead and create the function. Okay, so the function has been created. So let's go down to the code quickly over here. So this is what the default code would look like, but I'm going to drop in a bit of code that I've got here that we want to use. So what that is we are going to extract the finding severity counts field from the payload that we receive from EventBridge. And then we're going to take a quick look and say, are there more than 1 or 0 high severity counts? If there is, go write something in our log so we can see it. So this just illustrates that it picks up something that we want to action on. How you action it is entirely up to you. Recommendation here is that it sends some kind of alert to somewhere that you are at least aware of it. You can obviously go a bit more extreme and configure Lambda to go and delete that image should you want to. There are quite a few things that you can do. But let me now show you what the test payload would look like. So we're going to go over here and create a test event quickly. And I'm going to paste in the values and this, just call it event bridge for now. And this is what the packet actually looks like. So what you can see over here is I tested this on a different account. It gives you some details around when it happened, what account it happened in, what repository it happened on, and then also as well as the SHA of the image and then the different severity findings that it had. So let's just quickly create this and make sure that our Lambda is working as expected. So let's go ahead and hit the test button. Okay, it seemed to have worked. And if I scroll down here, I can see that we didn't get our log. And the reason for that is that I didn't hit save. So let's quickly do that. And let's try this again. Let's hit test now. Okay, now we can see over here that we had that alert being logged over here inside our logs. So know that the Lambda's logic is functioning. Now what we need to do is we need to be able to connect the scanner completing the event and raising this event and this Lambda actually consuming it. And that's where we're going to use Amazon EventBridge. So let's head over to that part of the console quickly. So we're just going to create a rule. I'm not going to spend too much time explaining Amazon EventBridge, but I do recommend that you go play with it. It is super useful. So we're going to create a rule, and we're going to call it, once again, ECR CVE scanning. The description is going to be event for completed CVE ECR scan. We are going to use an event pattern, and we are going to choose from one of the predefined services. We're going to pick AWS as the service provider. The service name, we are going to go for Elastic Container Repository. Here we go. Oh, sorry, container registry. And the event type we're going to be looking for is the image scan. And what you can see over here, if you click, is that's what a sample event looks like if you want to go play with it a bit. But we scroll down a bit more. We can leave everything on defaults over here. And then the target that we want to invoke is going to be that Lambda that we've created. You can add multiple targets should you want to. In our case, we just want this one. So let's go ahead and create this. So now I've got this in place. So now all that I need to do is to push another image up so that we can see that the scan is run and then our Lambda gets invoked. So let me quickly just go back to Lambda. I just want to show you that the source is now linked from EventBridge to it. And if I click on a Lambda, now what you can see in this visualization over here is that we've got that CloudWatch event, EventBridge, actually triggering our Lambda. But what we want to do is we want to push another container quickly. So I'm going to pull a different Ubuntu image. The reason for this is that if you push the exact same image, it'll actually pick up that the SHA is the same and just add that tag to the existing one and not rerun the scan. So now we're just going to tag it and push it again. So let's quickly do that. And we can see it running over there. And let me head over to the Lambda and we could take a look at the logs. Okay, so I'll just go to monitoring over here. And I'm going to hit view the logs in CloudWatch. So what we can see over here is the latest one. And this is what just happened. And we can see over here, if I expand this one, that we had it actually trigger on that alert. So like I mentioned earlier, if there is something that you want to do in terms of action you want to take, just build it into the Lambda and you can decide how you want to treat this, any CVEs that you see coming up. So for the next part, we're going to take a look at how to use those auto scaling group allocation strategies for a ECS cluster. So let's clean up our tabs a little bit. And then we're going to head over to ECS over here. And then we are going to create a new cluster. And then we're going to go head over and create an auto scaling group for it. We are going to create a EC2 Linux networking group one. We're going to call it ECS Spot. And we are going to create an empty cluster for now because we will be manually creating the auto-scaling group for this cluster. So let's go ahead and hit create, and our cluster has been created and we can view it over here. So now for the auto-scaling group, we need to head over to the EC2 portion of the console and scroll down here on the left, right to the bottom to auto-scaling groups. Then what we need to do is to say, let's create a new one. And we are going to pick one using launch templates. You have to pick launch templates if you want to make use of these advanced features where you can combine the different instance family types and the different spot pools for it. I've created a launch template for this already, and we're going to just use it. Okay, so let's give our a name. We're going to call it ECS Spot. We're going to use that launch template that we selected, version 1 of it, which is the only version at the moment. Then for the fleet composition, we're going to say combine purchase options and instances. So the first thing we have to do is we want to pick the different types of instances we want to use. So let's say we went for a T2 large, which has got 2 CPUs and 8 gigs of RAM. I can add that. I can go for the T2.extra large and add the T2.2x large. And then also finally, let's throw in a C5 large. And now in terms of the weights, let's assume that our T2 large is our base unit. So we give it a weight of 1. This one is double the size, so it has a weight of 2. This one is doubled up again, so this is a weight of 4. And then finally, if we look at the specs of the C5, it's got 2 virtual CPUs and it's got 4 gigs of RAM. Now, I'm going to assume that my metric that I'm concerned about is vCPUs in terms of my compute units for my weights. Therefore, this C family one will get 1 as well. Now what we can see over here is the instance distribution. There's a default mode, but we want to go and actually specify it. Sorry, just misclicked there. We're going to use the on-demand allocation strategy, which is prioritize. And what this is that it'll pick the instances based on the priority of the list that you provide. So it's going to start off with T2 large, then T2 extra large, then T2 2x large, and then finally C5 large. Then for the spot prices, you can use the default, which is the same as the on-demand price for those instances. So worst case, you will pay an on-demand price if the price should surge up to that level. Just quickly, let me show you how you can see what the spot prices were in the past. For that, we need to head back to the EC2 console. So I'm going to open it up in another new tab over here. And then on the left here, you would go to spot requests. And then you can look at the pricing history. So let's take a look at the pricing history for the T2 large that we had. It's down here, and we're going to select it for the last 3 months. So here you can see that it's been pretty flat. There was a slight bump over here where it went up like a few cents for a few days, but that's about it. If we look, for example, at the C5 large, we can also see that this is fairly flat, and the spot prices tend to be fairly flat unless it's a very specialized, very large or expensive instance type. So you can come have a look here to get a feel for how often they change. Also, interesting metric that people would be interested in is to know that over the last 3 months, we've only terminated 5% of all the spot instances that were launched across all our regions worldwide. So you've only got a 5% chance in terms of that instance being terminated. So let's go back to the management console for the auto-scaling group creation. So now we know what the allocation strategy is and the spot pricing. We need to pick the spot allocation strategy. Now this is where we can choose between the instances to be capacity optimized or to optimize for the lowest cost. And when you pick the one for the lowest cost over here, you'll see that there's another variable in here that you need to set. What this is that this indicates the number of instance pools that you pick or instance types that you pick out of this list. So by specifying 2 for the spot instances that we're going to launch, we will only look at T2 large and T2 extra larges. But if you want to look across all 4 of them, you would need to increase that to 4, because now it can take all 4 into account when it tries to find you that lower price point with the weights taken into account. Then the next configuration is that you have to pick how many of the instances that you launch will always be on-demand instances. And you can specify like this with this parameter where it says designate the first X number of instances as on-demand. So for our case, we're going to say we want the first one to be on, actually let's make it 2. The first 2 to be on-demand instances. And then of the remainder that you need, what percentage needs to be on demand and what percentage needs to be spot. And this you can change based on your needs. So let's say you have got a workload where you just want to use a bit of spot to augment it. You can leave it at a high on-demand percentage. If you can, for example, restart your workload and you want to optimize for cost saving, you can take this down or down to 0 should you want to. So I'm going to leave it at, let's make it 35%. To use. And then also in terms of the group size, this is the desired size that we want to use when we launch our autoscaling group now. So I'm going to start with let's make it 4 instances, well not 41, 4 instances to make it a little bit more interesting. One other section in the console I just quickly want to show you is when you need to pick these different instances. You can obviously, when you look at this drop down over here, see the basic values like the vCPU as well as the memory, but nothing else. What you can do is you can go to the EC2 console again, and over here, if I close this, you can go over to this section called instance types. And what this allows you to do is to actually look at the different instance types that are available inside the region that you are trying to launch instances in. And you can filter based on what your requirements are. So in our case, let's say our requirements are instance family. So I'm going to look at the, let's say, T2 family. I'm also going to look at the C5 family. And then I want to add a vCPU, a requirement over here, because that's our metric that we have. So we want to say we need more than 2 vCPUs, and let's say we want to have vCPUs less than 4, but more than 2, because the sweet spot for us might be between 2 and 4 cores. Then we confirm this, and then what we can see in this list over here is all the different instances that match that criteria that we just specified. And we can see that it's the C5 large, the C5D, the C5N, T2 large, and T2 medium. Now, the one thing that bugs me here is that I only see instances with 2 vCPUs, and when I look at my filter here, I can see it's less than 4, and it needs to be less or equal than 4. So let's quickly just fix that. So I'm going to go vCPU again. And then we are going to make this less equal to 4, so 2 or more, and less than 4 inclusive. So now what we can see is we get quite a longer list over here. We can see the different architectures. So if you do want to figure out which instances are the ones with specific characteristics that you need, definitely come look in this section, the EC2 console, to learn about that. But let's head back to our autoscaling group and continue the creation of it. So now the last section that I have to set here at the bottom is the network, and there's only one VPC. I'm using the default one to select. And then also we have to pick the subnets that this autoscaling group can deploy in. So we're just going to go ahead and select all 3 of the available subnets in here. And then the last section over here under advanced, there are quite a few options available here, and we can see that we can, for example, set it up to receive traffic from load balancers. In our case, we're not going to be doing that, but if there are any configs over here that you need, you can just come set them over here. We're not going to need them today. Next, we need to configure our scaling policies. And here you can decide if you want to keep this group at the initial size, so those 4 instances we specified, or if you want to add a capacity scaling policy, for example, average CPU across the whole group, or network utilization. You can also, for example, use the application load balancer request count per target if this autoscaling group is part of a application load balancer. So this is how you would normally scale up autoscaling groups. What we are going to show a little bit later is how this group will scale up and down based on ECS capacity demands. So we don't want to add any of this. So let's just leave it at the initial size. Cool, so let's head over to the configure the notifications. We don't want a specific notification if any scaling event happens. We also are going to add a tag for instances as they come up. We're going to call them EC2 worker nodes. And these will be when the EC2 instance is actually created. And now finally we can review this list of all the different configuration options that we chose. And over here you can see in brackets we've got the T2 large with a 1, extra large 2, 2x large with 4, and those are the weighting parameters. You can see all the other values that we have selected over there. So now let's hit the create button. So we can see that it has created. So let's go back to our autoscaling groups over here. And we can see that it currently has a desired capacity of 4, minimum capacity of 4, and maximum capacity of 4. Currently, there are no instances in service. The reason is that if we go to the activity history over here, we can see that it is busy spinning up some new instances for us. So let's go take a look at what it is busy spinning up for us by going to the instance section here in the console. So at the top there, you can see that is my Cloud9 environment, so we can ignore that for now. And we can see that we actually created 4 individual worker nodes, and we are using 3 T2 larges, and we're using 1 C4 large. And if we head over to the spot requests over here, we should be able to see that at least one of them should be spot, I think, if you think of the percentages that we applied. Yeah, so here we can see that we've got one that's currently as a spot in that pool. The reason for this is that, remember, we set our base on demand that we want at 2, and then we said split 35% on demand and the remaining 65% spot instances. And because we've only got 4 instances, 2 of them already on demand, and then using that percentage split, it meant that we got 1 each of on demand and spot. So while these worker nodes are spinning up, let's go back to our ECS cluster and just quickly reload this page. Okay, and I can head over to this ECS instance tab over here, and currently we can see that we don't have any EC2 instances, ECS EC2 instances inside the cluster, because they're still in the process of being spun up, and they haven't yet configure themselves or register themselves against the cluster. So if I hit refresh over here, so now we can see that all 4 of those instances are up and they have registered themselves against this ECS cluster. So now the next step we have to do is to quickly launch some tasks. So let's create a service by using those task definitions. So we are going to launch the EC2 type over here, and we are going to make use of that predefined task definition that I have. Our cluster is going to be this ECS spot cluster. We're going to just call the service Nginx EC2. We're going to make use of the replica service types, which is just launch X number of copies. If you select daemon, it'll launch 1 instance per host that we have in our fleet. So number of tasks that we want is, let's make it 6. And for these 2 percentages, this applies during deployment. So what's the minimum healthy percentage of instances that we want running? And we specify 100%. So we will at all times have at least 6 copies of this task definition running. And the maximum percentages, we can go up to 200% of that. So we can double our capacity, which means that we can spin up 6 additional new versions and then tear down the old 6. And that's how we do our rolling deployments. We're going to leave it on a rolling update for there, and we're not going to make any task placement changes for the moment. So let's go to the next step. Let's scroll to the top. We're not going to be using a load balancer in this integration because we are focusing on the capacity management of this cluster and not the external facing configuration. We're also just going to disable service discovery for now to keep it nice and simple. And over here, we have got the option to do autoscaling. And this once again is the same as we had previously. So if you want to change the settings of the number of tasks, for example, when it spins up desired numbers of tasks, you can come set this over here. And then also down here, with regards to the automatic scaling of the policy, you can now set to increase the number of copies deployed based on, for example, average CPU utilization or memory utilization, or if this was connected to an application load balancer, you can increase the number of tasks based on the application load balancer request. So this is for increasing and auto-scaling the number of tasks that you have running inside the service. For now, we're just going to leave it running level, and we're going to head over to the next step. So now we can review what's happening over here. So let's go ahead and create the service. And now we can go view the service. So just hit refresh, and over here we can see that we actually have got 4 of our copies running already instead of 6. Now the reason we only have 4 running instead of 6 is the way that I configured this task definition is to make use of host networking, which means that we share the ports between the container and the actual host. And since we can't map the same port to more than one container or more than one process, 2 of the containers currently can't spin up. And this is where we're going to lead into the next section, which is how do we make our cluster be able to auto scale when it runs out of capacity to run the number of tasks that we want it to. So for that, we head back to our cluster over here. And then you can see here on the last tab, we have got capacity providers. And what a capacity provider is a mechanism for ECS to interact with auto-scaling groups to increase or decrease the capacity that we have in that group based on metrics from within ECS. So at the moment, if we want to launch 6 tasks, but we don't have enough hosts that we can launch them on. So what I want to do is I want to add a capacity provider to allow ECS to go and increase the number of hosts that we need. So let's go ahead and create a capacity provider. Okay, we need to give it a name, and we can't use AWS, ECS, or Fargate, so let's just call it Summit Demo for now. And the auto-scaling group that we're going to pick is the only one that we have available there. And then the next section here is where we choose between managed scaling or not. And it's enabled by default. And this means that ECS will take over the decision-making between or for the auto-scaling group in terms of scaling in or out. The other decisions made by the auto-scaling group are no longer going to be applied. So we're going to enable this because this is the behavior we want. And then we have the next section here, the target capacity. And this percentage will be the amount of capacity inside your fleet. So if you set this to 100%, it'll only start scaling when you have your fleet entirely full. So we don't want that because that means we will be out of capacity. So I'm going to set it quite low. So let's set it at, let's say, something to 30, because I want to see a fairly large scaling event happen now when we go and enable it. Then in terms of the termination protection for the EC2 instances, we are going to disable that for today. And then we go ahead and create this capacity provider. So let's go back to our cluster quickly, our ECS cluster. And if we look at our ECS instances, now we can see that we are currently still on 4. So let me just refresh that. And we're still stuck at 4. So let's head just over back to our auto-scaling group and just take a look at the configuration over there. Auto-scaling group. And here we go. So what we can see over here is that we've set the desired to 4, and we have the min and the max at 4. And that max of 4 is currently the problem that's preventing ECS from scaling for us. So let's go ahead and edit that value quickly and make it something larger. So we need to scroll down here a little bit. We're going to set maximum to, let's make it just 50 in case we want to scale up. We're going to set the minimum down to 0 as well. And then we're just going to save this. Okay, and if I refresh now, I can see that it's actually increasing. And over here, we can see that we're now going up. It's desired 14 and wants 13. And this is just because I set that utilization percentage so low, because I wanted to illustrate how it's going to automatically scale up our instances for us. Now, if I go to the activity history over here, I can see that we've got a whole bunch of new EC2 instances that are not yet in service. We can see them over here. And let's just wait for it to load. And yeah, here we can see a whole bunch of them currently being spun up. And here you can see how we are now nicely spread across the different instance types that we're dealing with. We've got T2 larges, T2 extra larges, C5 larges, etc. And if we actually go back to our auto-scaling group down here, and we take a look at the instances, so we have a desired count of 14, and we've got an instance count of 13. So this is because if we went back and look at the list, we had one extra large, which counts for 2 in terms of our weighting. So let's go back to our ECS console quickly and refresh our ECS instances over here. And what we can see now is that we have got a whole bunch of them running, and we can see that where the tasks are running. And then lastly, we can now look when we go to our service over here, let's say the Nginx service, we can see that our desired count is now 6, and we do have 6 of them running. So this is how you can configure your ECS cluster to actually automatically scale up and down based on how much capacity you need. You can actually set up ECS to start off with an empty cluster with 0 instances in the auto-scaling group. And then as you start deploying your first containers, you can start spinning up more EC2 instances. So the last item we want to cover in today's list of services is how to create an ECS cluster using Fargate and then balance your service between Fargate on demand as well as Fargate Spot instances. So let's go ahead and quickly go create a new Fargate cluster for ourselves in ECS. So we hit the create cluster button. We're going to select powered by AWS Fargate. Then we hit the next step. We're going to give it a name, ECS Fargate. And then we're not going to be creating a VPC because we're going to make use of the existing one. So let's go ahead and create our cluster quickly. And then we are going to go view our cluster over here. So the cluster is currently in the provisioning. It should be done already. It's a very quick operation. And just quickly to cover, for those not familiar, what Fargate is. It is a service that allows you to run your task definition without having to provide EC2 instances to run them. We take care of that for you. So you just create a task definition which consists of 1 to 10 different containers inside it, and then you tell us how much RAM and how much CPU you want, and then the number of copies you want of that service to run. And then we take care of actually spinning up the infrastructure in the background and deploying and running those containers for you. So you no longer have any specific capacity planning. By default, the Fargate clusters come with 2 capacity providers. You'll see them over here. And you can see there is the Fargate provider and there is the Fargate Spot provider. And what this does is, this is how it actually knows what capacity to use when it launches Fargate. So let's go ahead and quickly launch a service. Just hit create over here. And if you launch the service normally, you would now just select Fargate over here and then select the right task definition and then fill in the values as per usual down here. But what we want to do is we want to blend on demand along with Spot. So we're going to say switch to capacity provider strategy. So let us add a provider and we're going to select the Fargate one. We're going to add the Fargate Spot as well. And what you can see happen there is as soon as I added the second one, we had the split between the two with a field for base and a field for weight. The base field over here indicates the number of instances that you want, or number of copies of the service you want running for that specific provider. So if we set this, for example, to 2, it means that we will always launch 2 of the task definitions using normal Fargate. I could also obviously set that to Spot. You can only set this value on one of the 2, not on both. So this is similar to that capacity provider for the minimum number of on-demand instances we saw in the auto scaling group. Then what we have over here is the weighting. And how this works is, once again, if we change this to 4 over here. So if, when I launch more task definitions, it means that for every 1 that I launch on normal Fargate, I will launch 4 of them on Spot. Then we need to go down here for the rest of the settings. We are going to use that Nginx Fargate definition that I've pre-created to this demo. Cluster is going to be ECS Fargate, and we're going to call this Nginx Fargate. This is going to be a replica by default, and now we have to pick the number of tasks that we want to run. So what we can see over here is we're going to have 2 Fargate ones. We've got to wait 1 to 4. So what I'm going to do is I'm going to set it to 6. So I'm expecting 2 to be over here and then split it 1 to 4, which means I'll have 1 additional one in the Fargate provider, bringing it up to 3, and then there will be another 3 missing, which will be for Fargate Spot. So that's what I'm expecting. So let's go ahead and see if that is what we will get out at the end of this. Then similar to the normal EC2 cluster, we have got those deployment percentages over here, and we're going to make use of the rolling update. So let's go to the next step. So scroll up to the top again, and over here we pick our VPC again, and we pick our subnets. Let's just select all of them quickly. And then we need to pick the security group for this specific set of containers. I'm just going to leave it as is because we aren't actually going to interact with the containers today. And over here, because we are deploying in a public subnet, we can auto-assign public IPs to it. We don't want to do that because you will should be putting these containers behind a load balancer of some kind. We don't have the health checks option because we're not using a load balancer. Leave the load balancer to none. And down here, we're going to disable the service discovery integration again. And then we're going to head over to the next step. And over here, we've got that ability to let our service or number of task definitions scale automatically based on different metrics should we want to. So for today's demo, we're just going to leave it to on the service desired count. We're going to go into the next step. And now we can quickly review all the options that we have selected. And then ultimately, we click on Create Service over here. And we can see that it's created the service. So let us quickly go jump to the service over here and see where we are at. So we can see at the bottom is that we now have got the service busy provisioning. We can see that the pending is 5 out of 6. If I refresh this, we are pending 6 out of 6. So the provisioning stage is when you're requesting the hardware to or the infrastructure to run those containers on. Pending means that that infrastructure has been provisioned, and we're in the process of pulling the image and starting up the 1 or up to 10 images that we have configured. Now, if I refresh it again, we can see that all 6 of them are currently in a pending state. Let's give them another second or two. Let's refresh. Let's do it once more. Okay, and we hit refresh again, and what we can see over here now is that we have got 5 out of our 6 already running. And if I refresh it again, we can see that last one is still pending. So let's quickly take a look at one of these tasks over here, the first one. We can see that this one is running on Spot. If we go back and we select the second one, this one is running on normal Fargate, so it's 1-1. Third one is on Fargate, so 2-1. Fourth one, Fargate 3-1. And Spot again, and then I would expect that last one to be Spot again as well. So yes, perfect. So what you can see now is obviously on the individual tasks, you can drill down into these configuration options should you want to. But what you can see here is now that this is how we weight our capacity between the on-demand versus the Spot versions. And the reason you would want to use Spot is that they are about a third of the price of the normal on-demand cost of using Fargate. So if you have got workloads where you don't mind if they get interrupted, sell them, because remember, this uses the same underlying Spot instance infrastructure as we have with our EC2 instances. So you should also be looking at that 5% termination rate spread across all the different regions in the last 3 months. So if you have got those workloads, this is a very, very good use case for that. So thank you very much for joining the session that I did today. I hope you learned something with regards to how to make use of Spot instances and how you can blend them into your order scaling groups, give them different weightings to figure out exactly what different instance types you want to build up the exact worker fleet that you need. And also how to then balance between on-demand Fargate instances as well as Spot instances for Fargate. If you've got any questions after this session or in future, please connect with me on social media on either LinkedIn or on Twitter. You can see my details on the screen in front of you. And then also we have got a mechanism inside the platform that you're viewing this through. If you could go and rate this session, I would really appreciate this. We use this metrics to figure out what topics we should be focusing on for future sessions. And with that, we are done for today. Thank you very, very much for joining my session. Goodbye.